ACCUFAS is a joint project between AMRC and IONA, looking at improving a robot's accuracy through photogrammetry and machine learning. IONA is capturing positional data from the robot's tool. We're capturing data out of the robot controller as well that is telling us where the robot thinks it is in space. We're also collecting current data out of the robot controller so we can infer torque in each of the motors. This data is going into a training set that will train the machine learning model to anticipate where the robot will be more inaccurate and where the deflection might be higher. The machine learning will then suggest corrections to a robot path to hopefully get us a more accurate part at the end of it. This screen shows the IONA control software, which is called Aura. There's a little CAD end effector that is modelled on the real one there, and the simulation in Aura is being fed with live data from IONA to update this position and is measuring in the background.
IONA assessed its product at what accuracy it currently has and what the industry were requiring. It's currently set at 0.3 millimeters at 3 Hertz. And the industry we talked to were looking for a 10 Hertz system at 0.1 millimeters accuracy. The way we increased the frequency was improving our software algorithms, both on the node and on the controller, increasing the frequency from the 3 Hertz to the 10 Hertz required.
I think it could make automation cheaper in the long run for aerospace. A system like this is certainly cheaper than a big bespoke machine. So you'd improve flexibility of your cells, and it could be retrofitted relatively easily. We'd like to look into feed-forward real-time control of this robot, backed up by positional data from IONA. We feel that we could take in-process data and inform the next step of the program to account for new deflections in the machining itself.
NATEP has given us the opportunity with their funding to run this project and work collaboratively with the University of Sheffield here at Factory 2050. They have also assisted us with exploitation opportunities which we wouldn't normally have had, such as filming or attending conferences.
As the NATEP Technology Manager, the ACCUFAS project brings together core aspects we know make a successful NATEP project. We have IONA with their optical technology looking at being able to measure accurately the positions and tool paths of a robotic system. And then we have the AMRC based here at Factory 2050 with the robotic systems, the machine learning expertise and technical guidance to be able to help make this project a success. Together they've collaborated to demonstrate this technology is capable of achieving the level of requirement and accuracy needed of the aerospace industry, but also showing that it is possible to do that with a robot, in this case with milling, to be able to show that it is a viable technology to bring that into the industry.